This is GSP Saturn, a cantilever-type, self-elevating mobile offshore drilling rig. It was built as a slot-type drilling rig in 1988 by Galați Shipyard, Romania. The rig was significantly upgraded in 2004. In 2009, GSP carried out an extensive upgrading project, investing $68.5 million and financing over 60% from GSP's own funds. The upgrading project was completed by GSP under the American Bureau of Shipping Supervision. Due to the new cantilever beam, GSP Saturn increased productivity by 67%, being able to drill up to 27 wells in the same location compared to only 9 wells capacity of the slot-type rig. The 265 cantilever, sizing 30-meter length and 18-meter width, can be extended outside the rig, reaching a drilling envelope of 55 by 20 feet. The cantilever sustains outside the rig the derrick and the 750-ton top drive. But let's not rush into things. First things first. Safety first. You need solid safety rules when you live way away from the comfort of the land. So, for example, if you know how to use survival kits, like this breathing apparatus, and you follow all safety rules, you'll be just fine. With 100 or so crew on board, you need those safety rules, and you also need accommodation. The accommodation conditions on board the rig comply SOLAS requirements, as well as flag and international standards and regulations, and it's quite comfortable. However, people need more than just a bed with a curtain. Fresh water is a must. And this is where they make it, desalinization plant. Then part of it is heated, and off it goes, pumped through tens and tens of pipes. Now let's go to some of the heavy and very noisy stuff, the power plant. 5 powerful Caterpillar generators, plus an emergency one with a total of more than 8,430 horsepower, are capable of powering up this entire sea giant and leave enough light for you to read your favorite author when your shift is over. Controlling that much power requires dedicated room and specialized supervising. The belly of this engineering giant is filled with big, large machinery and installations. And this one is impressively large. Here are the 131 cubic meter cement reservoirs. This is the place where they make the special mixture for building the shaft walls. But we'll get back on this later. Of course, those 100 people on board are not left by themselves in the middle of the sea. A permanent radio link makes a connection between the shore and the rig. Just in case you might hear it on the air, the GSP Saturn call sign is 3ERX8. Some other links to shore can be made by sea, or even flying. The 635 square meter helideck is complying with the CAT 435 regulations, and it can support birds of up to 8.6 tons in weight. You've probably seen by now the 4 incredibly large pillars, the rig's legs. They are 121.6 meters tall, enabling the rig to operate at 91 meters water depth. The extraordinary thing is that they move. They can be raised or lowered independently of each other. Well, actually, the platform moves up and down on them, and here is where they control their movement. GSP Saturn is towed to the new drill site with its legs up and the barge section floating. The ocean transit draft of GSP Saturn is 32 feet, 9.75 meters. Upon arriving at the drilling location, specially trained personnel, the Marine's operations team, control heavy machinery to jack the legs into the water, jack down onto the seafloor, preloaded to securely drive them, and jack further down into the sea bottom. The drilling rises above the water. The entire barge and drilling structure are slowly raised above the water to a predetermined height, the air gap, so that the wave, tide and current do not reach the barge and drilling equipment. The drilling rig reaches the maximum drilling depth of 30,000 feet. When it is time to relocate, the platform goes down to the sea level, the legs go up, and the whole steel structure floats. And the drilling rig is 52.4 by 40.8 meters. Basically, it's half a football field. Moving a jack up is critical operation, and GSP often performs operations of the kind, the marine operation teams mastering the processes. The legs are so big and incredibly adapted to rough sea conditions, so the rig may be perfectly operated and controlled under a 50-knot wind and 30-foot waves. The bottom-supported offshore drilling rig is designed to successfully face storm conditions with 86-knot wind and 39-feet waves. That's 150 kilometers per hour wind speed and 12-meter high waves. And now, the reason this enormous giant stands tall in the middle of the sea. The drilling operation. It's a complex process with certain steps to follow, a very laborious endeavor. The drilling equipment includes the NOV draw works, driller's cabin, top drive, and pipe handler. The Upetron derrick, 164 feet by 30 feet, and rotary, 37.5 inches in opening independent drive, mud pumps, dual motions Mongoose Swacco shale shakers, Swacco desilter and desander, dual motions Mongoose mud cleaner. The cast of this main act are the top drive, the iron roughneck, the catwalk, the pipes, the pipe handler, one piece of mud bucket, or maritza as they call it, one piece of state-of-the-art drilling equipment, cyber chair control, the NOV Amphion system driller's cabin with dual chairs, some other not so big and not so visible devices, and, the most important, GSP's professional crew. So after they set the rig in place, the show begins. You cannot say which one has the leading role, but you can't escape the feeling that the 750-ton top drive is the most impressive of them all. Not only does it look, but it is indeed powerful. Its main purpose is to push in and take out the pipes. The top drive ensures the necessary hydraulic forces. The heavy hydraulic motor suspended in the derrick of the drilling rig rotates the drill string and bit assembly. The use of the top drive has eliminated the need for traditional Kelly and rotary table. Therefore, the amount of manual labor and associated hazard that have traditionally accompanied this task have been eliminated. Every single operational moment is a demonstration of how impressive the today drilling technologies are. Now, they bring in the iron roughneck. The iron roughneck maximizes the efficiency of pipe handling operations by providing integrated spinning and torque-making capabilities into a single machine. The robotic equipment increases safety for the entire drilling operation, as well as, more importantly, the personal safety of the crew. Controlled through integrated drillers' control stations to automatically perform complete make-break cycles, it provides increased levels of automation of GSP Saturn. In order not to waste the mud, they put maritza over the joint. Its real name is the Mud Saver, but when the going gets tough, you need to fun up the place a little bit. Now enters the pipe handler. It gets a grip of the situation. Its purpose is to take away the pipes, the controls being in the cyber chair's driller's cabin. The innovative design of the pipe handling system of GSP Saturn is proven to significantly reduce certain hazards associated with direct handling of tubulars during the pickup and laydown process, reducing or eliminating the handling of tubular by the use of robotic handling. But after digging quite deep, you need to strengthen the walls. After drilling a section of the well, the newly driven interval is sealed off with steel pipe to ensure integrity for the following well section. Remember those big cement reservoirs? This is the moment they enter the scene. The cement is introduced in the annular space between the outer wall of the steel pipe and the well bore. This creates a seal so that outside materials cannot enter the well flow, as well as permanently positions the casing in place. It looks easy, well it's not. You need the latest technologies and the most modern machines in order to have the results the company and the client expect. It doesn't end here, there's more to come. Imagine the quantities of soil dug up by the bit. It needs to be taken out somehow. For that, they use mud, a special liquid mud. Thinking of the mud, you might say it's a dirty job, but it actually produces zero pollution. For a deep well, you need a lot of mud and a big tank to make it, by certain recipes, and to hold it. From here, up it goes by means of some impressive pumps. 3 XXX 1600 HP each, to the drilling deck and back into the well. Because this is a circuit, they pump mud back into the well, but they have to take it back using the friendly Maritza. Through a special gutter, the dirty mud goes into the mud cleaner, a set of vibrating sieves, and back into the circuit. It's a 24/7 process. GSP Saturn is not only working like a well-oiled machine, it actually brings out the oil that lubricates the machine. And from a distance, it looks like a big mean machine. Close up, it is clearly a modern and highly efficient technological island, safely sustaining the energy balance. When it works, it brings benefits to a sea of people.